Hi everyone, good morning. Hello. Yeah.
Everyone.
Hi everyone. Good morning, everyone.
Good morning, everyone. Hope you all are doing great. Um, just give us like a little bit of time, 1 minute or 2 minutes, so everyone can join, so we can start. On behalf of the entire Wave Hackathon team and ACM Seattle SIG KDD chapter, I want to extend a very warm welcome to all our participants, judges, mentors, speakers, and guests joining us today. Wave Hackathon is more than just a hackathon. It's a place where ideas become reality. It's a space where students, professionals, creators, and innovators come together with one common goal to solve meaningful problems, learn from one another, and build something that can create a real impact. Over the course of this event, you will collaborate with talented teammates, receive guidance from experienced mentors, hear from inspiring industry leaders, and challenge yourself to think beyond what's already been done. Whether you're writing your first line of code, pitching your 100th idea, or simply here to learn something new, every one of you is contributing to the spirit of this community. At Wave Hackathon, we believe innovation doesn't happen in isolation. It happens when curious minds come together, ask bold questions, and aren't afraid to try something new. That's exactly what this event is all about. Before we continue, I would also like to take a moment to recognize our technical sponsor, the ACM Seattle SIG KDD chapter. ACM Seattle SIG KDD is one of the world's leading communities for data science, knowledge discovery, and data mining. Throughout the Seattle chapter, we bring together data scientists, machine learning engineers, researchers, and AI practitioners to learn, collaborate, and build the future of technology together. The chapter regularly hosts technical sessions, workshops, and conversations with industry leaders, creating a space where people can go beyond the hype and focus on building real world AI and data driven solutions. I encourage everyone to check out the ACM Seattle SIG KDD website at seattle-acm.org to learn more about upcoming events and ways to get involved. One exciting event coming up is the ACM Data Conclave on July 30th as a part of Seattle Tech Week. It's a great opportunity to hear from leaders in data, AI, connect with the community, and continue learning. This hackathon truly reflects that same mission, bringing together talented minds, encouraging collaboration, and giving innovators a platform to turn ideas into reality. We are incredibly grateful to everyone who made this event possible: our organizing team, judges, mentors, sponsors, speakers, and of course, every participant who chose to be here today. And speaking of learning from experience, one of the greatest opportunities a hackathon can offer is the chance to hear from people who have built companies, mentored founders, and experienced the entrepreneurial journey firsthand. Today, we are fortunate to have someone who embodies exactly that. It's my absolute pleasure to introduce our keynote speaker, Brett Waters. Brett is a lifelong Silicon Valley native. Though if you ask him, he'll tell you he's mostly stayed there because the local fish tacos are unparalleled. Culinary priorities aside, Brett brings a tremendous amount of first-hand entrepreneurial experience to us today. He currently teaches entrepreneurship at Stanford, serves as an executive mentor at the Miller Center for Global Impact, and provides one-on-one coaching for startup founders navigating the challenges of building companies. His track record as an operator and leader speaks for itself. Previously, Brett was the founder and CEO of three different Silicon Valley software companies. He also dedicated a significant time to education and mentorship, having spent 6 years on the advisory board of Stanford University Graduate School of Education, currently acting as an interim CEO at Stanford New Schools and serving as a chief mentor with the European Innovation Academy. He earned his MBA from Kellogg School of Management at Northwestern University, which, as he likes to point out, is an incredibly prestigious institution, even if their fish tacos are strictly mediocre. Please join me in giving a very warm Wave Hackathon welcome to Brett Waters.
Thanks very much. I appreciate it. So, hey guys, I'm joining you from Berlin, Germany this evening. I've been in Ukraine for a few days, helping the entrepreneurs in Ukraine. And it's beautiful here in Berlin. It's a very nice, beautiful summer evening. So let's see. I'm going to share my screen here if I can. Figure this out. There we go. Boom. All right. Everybody is seeing my screen now, right? Somebody give me a yes.
Yes, we could see yes.
Okay, so let's see. I'm Brett Waters. Been in Silicon Valley my entire life. I've been founder and CEO of three different software companies. Today I teach entrepreneurship at Stanford. I teach two courses. One is focused on the stage getting from a startup idea to product market fit. And then the other course I teach is focused on getting from product market fit to scale, because those are two very different, very different processes. I also coach startup CEOs at Miller Center for Global Impact. And I've had the pretty unique opportunity to be in Silicon Valley all the way from the Apple One. So the Apple One came out when I was 17 years old. And it was just about the coolest thing that I'd ever seen. And today, of course, it's all about agentic AI. And so I've had the pretty unique opportunity to be in Silicon Valley all the way from the Apple One to agentic AI and a whole bunch of things in between. So a couple of years ago, I wrote a book called The Launch Path, and it's based on one of my Stanford courses. And so it's about the steps for getting from a startup idea to a launched and funded venture. So I thought I'd start off by very quickly walking you through the 8 steps on my launch path in this book. And none of this is going to be, completely new for you guys. This is all stuff that you guys know. But I thought I'd kind of really quickly go through these 8 steps. And then we'll switch to the more interesting topic, which is how are things changing right now? Right here we are in the middle of 2026, and there's a lot of stuff going on. And I think creating a new startup in 2027 and beyond is going to be a little different than it has been in, even in 2025. So we'll get to that. But before we get to that, let me quickly walk you through the 8 steps on my launch path. So the first step is, where do great startup ideas come from? And Paul Graham, the co-founder of Y Combinator, he has an essay on this topic in which he says the way to think of great startup ideas is not to try to think of startup ideas. It's to notice problems worth solving. That's where most great startups begin, is with the founder who notices a problem worth solving. And then step 2 is, you're going to have to build something people want. And that seems really obvious. But during the dot-com boom in Silicon Valley, I got this completely wrong. So I had an awesome idea for a new software product. It was an incredibly awesome idea. And I convinced some venture capitalists that my idea was awesome. And they invested $5 million in Brett's awesome idea. And I used that money to hire a bunch of expensive software engineers and convince them how awesome my idea was. And we spent 2 years and $5 billion building Brett's awesome idea, only to find out that no customers wanted it. And so, having made that mistake once myself, I'm pretty passionate about the idea of doing rapid iterations in order to get to product market fit. Before you start writing a single line of code, you should spend a whole lot of time out talking to customers and understanding customers. So before you do product development, do customer development. Step 3 on my launch path is about the landscape of competitors. And I like to call it the landscape of competitors and alternatives, because most people think of their competitive landscape as being the other companies that do what you do, but you're also competing against the alternative ways of solving the problem that you solve. And that's a really big thing to remember. Some of you may remember 3 or 4 years ago in Silicon Valley, there was a startup called Juicero. They raised 120 million in venture capital, advertised themselves as the only Wi-Fi connected juicer on the market today. And they completely failed because there's a lot of alternative ways of making juice. You don't need a $700 machine to make juice. And so the point is, when you think about your competitive landscape, remember that it's not only the companies that also do what you do, it's also the alternative ways of solving the problem that you solve. Step 4 is about business model. And I define a business model as being the rationale by which an organization creates, delivers, and captures value. So we create value by solving a problem customers have. Now we have to deliver it to them via various channels, so via our website or via our mobile app or via our retail stores. And then we need to capture that value in the form of revenue. And step 5 is about spreadsheets. And it's a whole bunch of different things that go into the economic model for your startup. But fundamentally, it distills down just to one simple equation, which is customer acquisition cost compared to the lifetime value of a customer. How much does it cost us to get a customer? And then once we have a customer, how much can we make from them? And it seems really intuitive and obvious that if we know we spent $10 to get a customer, we better be able to make more than $10 from that customer. And yet, a leading reason that startups die is that they realize too late that their customer acquisition cost is too high compared to the lifetime value of a customer. Step 6 is about capital strategy. And that, especially today in the middle of 2026, there are more sources and structures of startup capital than ever before. And so make sure you choose one that aligns well with what you're doing. Many people just immediately assume that for a startup, you need some venture capital. Yeah, venture capital was actually a fit for a pretty small percentage of all new startups. There were other ways that are better for most startups. Step 7 is about framing a customer acquisition funnel. And that when you look at all the reasons that startups die, the number one reason is just simply not enough customers, right? Just plain and simple, not enough customers. So how do we make sure that doesn't happen to us? And then the last step on my launch path is storytelling. Every great entrepreneur has to have the ability to tell a crisp, clear, and compelling story about what she's working on and why it matters. It's just a fundamentally important skill. And people think of pitching as being pitching for money, but startup founders are pitching all the time, right? They're pitching for customers, they're pitching for co-founders, they're pitching for partners. So there's all kinds of reasons why this ability to tell that crisp, clear, and compelling story is a super, super important skill for entrepreneurs to have. Okay, so the question is, how is all that changing? Because right now there's a whole bunch of stuff going on. And so I'm going to kind of tell you so obviously AI is kind of the big trend, but there's also a bunch of changes going on with regard to capital, and with regard to the fact that we're in a place agnostic era today. It matters less today the place that you're in than ever before. So I'm going to give you 8 inversions that I think are changing the way that startups get built from this point forward. The first is, the whole agent thing. As you guys know, agents are like the hottest topic right now, and an awful lot of startups have died because they've hired too fast. And so I think moving forward, any startup founder should, before they make any hire, should ask themselves, could an agent do this job? And I think, increasingly the successful startups could be the ones that are run by 3 or 4 humans and a whole bunch of agents. That's the way in which startups are going to be run moving forward. Narrow is the new big, meaning that up until now, it's mostly been kind of big horizontal SaaS platforms, right? Think of Salesforce. Salesforce is a very horizontal platform. It supports all kinds of different businesses in all kinds of different geographies. And partly that's because the economics of building a platform like this has been such that you need to build it to be something that can add value to all kinds of different businesses. But today, as you guys all know, because you guys are all hackers, today the economics of building a new software application are just dramatically different. And so I think we're going to see a lot more vertical implementations. Why should tonight I'm sitting here in Germany. Why should companies in Germany be using American software like Salesforce and Oracle and Meta, right? Why shouldn't German entrepreneurs be building software applications that are specifically tailored for the German market, or specifically tailored for German fintech companies, right? And so I think we'll see a lot more vertical plays than we have in recent decades. Distribution matters. Distribution beats technology these days. Tim Connors, a very venerable Silicon Valley venture capitalist, told me one day, he said, all you guys, you talk about product market fit, that's great. But what matters is product market distribution fit. An awful lot of startups have failed because they developed a great product, but they never found the right distribution channels to sell it through. So distribution beats technology, especially today when the tech part is so much easier than ever before. Outcomes-based pricing. So as you guys know, the SaaS model has always been that, we charge you $100 per month per seat. And it doesn't matter whether you're using our software a lot or whether you're getting value out of our software or not. It's $100 per month per seat. That's our pricing. But wouldn't customers really rather have outcomes-based pricing where I'm paying for this software application based on whether or not I'm using it a lot, whether or not I'm getting a lot of value out of it? And I think that, in the AI world, it's pretty easy to measure that and to set up pricing schemes that are based on outcomes rather than the pricing schemes just simply be flat per seat per month. Revenue before headcount. This if you want to get funded today, you better be able to show that you can produce revenue right off the bat. This idea that we're going to be pre-revenue for the next 2 years, that's done. That's gone. The founder is the moat. So here's the thing: is that we've been through a few decades in Silicon Valley of thinking that for a startup, your moat, in other words, what protects you from competitors, is your deep technology, right? That our software platform, it took 5 engineers 2 years to write the software. It's 127,000 lines of code. It's deep technology, and that's what will protect me from competitors, right? That's what we've always assumed. But today, with AI, whatever deep technology you think you have built, probably somebody else with a gallon of coffee and Claude code can reproduce it in a weekend. And so don't think of your technology as being your moat moving forward. There are lots of other things that could be your moat. And as this slide suggests, I think often what this means is that the founder is the moat, right? That the founder has unique insights into customers. The founder has unique customer relationships. The founder has a unique business model they've developed, right? That those are the things that are going to protect you from competitors. It's not going to be your code base. The code base is not going to be able to protect you from competitors moving forward. Fundraising is less important than ever before. So the company that I mentioned before that I founded during the dot-com boom, out of the $5 million that I raised, I spent the first million of it just buying servers and configuring servers. Right today, that's 10 minutes on AWS and you're done. And so the amount of money required to found a startup, to grow a startup, to launch a startup is dramatically different than it was just 10 years ago. And the great thing about that, I think, is that founders can take all of that time that they've spent fundraising and spend that time with customers. That's a much more important use of your time than dancing up and down Sand Hill Road for months on end. And the capital follows talent. Up until a few years ago, if you wanted to create a new startup, if you wanted to found a new startup, you kind of had to move to Silicon Valley or maybe one of the other major tech centers, entrepreneur centers. But today, there's been this decoupling of centers of capital and centers of innovation. And I'm seeing Silicon Valley venture capitalists investing in startups all over the world today. So if you create a startup and you're successful, the capital will find you instead of you having to spend your time chasing the capital. And that's a pretty significant shift. So those are some of the trends that I see going on. And I honestly think the next decade is going to be a golden era for entrepreneurship. There's more going on than I've ever seen. Through my career, there was kind of one opportunity wave at a time. First, we had the semiconductor wave, and then we had the personal computer wave, then we had the internet wave, and then we had the mobile social wave. Each one of those lasted 10, 12, 15 years. There was a whole bunch of startup opportunity around that wave, and then we were on to the next thing. But today, it's like 5 or 6 or 7 significant trends going on at the same time. Not only AI, but climate technology, agricultural technology, autonomous vehicles, medical technology, right? Each one of these is a $1 trillion opportunity wave, and they're all going on at the same time. So that's my brief introduction, and I'm just Brett Waters on the socials. So I'd love to connect with you guys. And thanks.
Thank you so much, Brett, for the wonderful keynote session. Your 8-step framework was insightful and valuable for anyone looking to begin their entrepreneurial journey. We truly appreciate your time and contribution.
Pleasure.
And now we will move into the next exciting part of today's event, our project presentation showcase, where our teams will present the ideas and solutions they have been building. I will share the presentation schedule sheet in our group chat. Just give me a minute. Please let me know if anyone is unable to access this. Please take a moment to review it. You will find your team name, team members, project title, presentation order, and assigned time. To ensure a smooth presentation flow, we will be using 3 virtual rooms. Main room for all participants, speakers, and ongoing event activities. waiting room where the next presenting team will be moved and get ready before their turn, and presentation room where judges and the presenting team will join for their project showcase. Judges, please use the updated judging sheet that was shared with you today for your evaluations. Teams, when your presentation time is approaching, please make sure all team members are ready. Once you are moved into the presentation room, you will present your idea, demonstrate your solution, and share the impact of your project. Following each presentation, judges will have the opportunity to ask questions, provide feedback, and evaluate the project based on the judging criteria. Each team will have 8 minutes to present, followed by 2 minutes for Q&A with the judges. To all participants, this is your opportunity to showcase the creativity, effort, and innovation you have put into your project. Present with confidence, enjoy the experience, and make the most of this opportunity. To all the judges who are also speakers, you will be automatically moved from the presentation room to the main room when it's your turn to present. With that, we will begin moving our judges into the presentation room and start the Wave Hackathon project presentation showcase. If you have any questions, please message in the chat. Thank you. Best of luck to all the teams. We are excited to see what you have built.
I think now every judge has been shifted to the judging room. If anyone is left, can you please raise your hand?
Can you repeat your question, sir?
I asked if any judge here is left, just please raise your hand so I can move you to the breakout room for.
Shreyansh, right? You're organizing, right? Shreyansh?
Yes,
Yeah. So, hey, I'm Ankush Mahajan. I was supposed to present my book. So, can you give me a schedule for that?
yes, Shravani will provide you the schedule.
Yeah,
Uh,
Ankush, we will share it in a bit.
okay. Can you give me a tentative timing so I'll accordingly plan my day?
Sure. In the
Saicharan
list,
is in the speaking list, so he'll be right here. Saicharan is not a judge. I think the list that has been shared by Shravani consists of only the people who are here for judging or here for participants. Only
the
the
present,
participants.
yeah,
Yeah,
the
who are going
participants.
to present.
The others will be here in the main screen itself, and we
Yeah.
will announce them, yeah, as their turn comes.
So the list is only for the people who are going to present today. Other people, such as judges and speakers, are not in the list.
Uh, Hello again. So we'll be presenting or speaking against the audience, right? So if the speaking is done or the presenting is done, will there will be any audience or how it will work? Are you going to pull them back again together in one session or how it's gonna work?
So the
Only
speaking session and the judging session will run parallelly. The people who will be speaking will be here, and the people who are going to judge for the presentations will be moved to a separate room for judging. So, as far as you are concerned, you will be just here in front of the audience with every participant and other speakers.
Okay, sure. No.
I think every judge has been moved to their rooms now. Is there anyone left? I can see Mayank. Okay.
Cool. Should we kick off the speaker session?
Yes, Manushi, we are helping all the judges to move to our presentation room. Once it is done, yeah, we will start with the speaker session.
Awesome.
I think now we can start. Every judge is in the judging room. No one is left here. And I'll also move the first team to go present.
Sure.
Awesome. Yeah. Thank you everyone for joining us. We have got a great lineup joining us virtually across numerous domains today, such as fintech, cloud, data, and AI. So let's kick off things with Sri Ramakrishna, who is the product manager at Wingstack, who spent years building money movement and core payment system at PayPal, including a platform that generated over 100 million in first year of revenue. He's here to talk about the evaluation of the payment rails. So let's all welcome Sriram. Uh, Sriram, are you here? Yep.
Shriram is here.
Sriram, I think you're muted.
Yeah, hello.
Okay.
So I thought, I just got a notification saying, asking me to join the main room, but then there were some discussions with the judging committee. I don't know if any of the judges are in here. Is it just Shavni? Is that by mistake I joined here? Should I just go back to the judging room?
I think you are at the right stage. I think you are our first speaker. So if you want to get started.
Yeah, you can complete your presentation here, Sriram. Then we will move you to the judging room.
Okay, so anyway, okay, let me kind of get started. So very warm welcome to one and all. My name is Sriram. So I'm going to be one of the judges here, and I would be speaking on the evolution of the payment rails. This is into the cross-border payments and the fintech space. So first of all, before even we get started, just a quick bit of introduction about myself. I work for customers such as World Bank, the International Finance Corporation, Royal Bank of Scotland Group. I was with payments and fintech for a while. In fact, I worked for PayPal for like close to 11 plus years, and presently with a Series C startup. It's a cross-border payments company in San Francisco, and I'm heading the product division there. So, being a judge, I thought like I would just kind of bring you folks on page about like what changes are happening in the fintech industry and how is the industry shaping up or evolving. And we are going to discuss something about the Swift Telegram right into the very latest blockchain settlement, right? So that's kind of how the industry is shaping up. So like Brett mentioned, the first thing is like, what problem are we solving? It's just not about bringing the technology to the up-to-date version, but what are all the problems that we are solving? What's the key challenges that we have in this space? And how is the fintech, sort of like how is going to help the customers and the business needs and the problems that we are going to tackle? So the very old infrastructure that's in place is the corresponding banking infrastructure that's since 1970s. And Swift recently released something called as the Swift. It's a payment innovation that happened in Swift sometime around 2017. But unlike many folks who might be aware about Swift, it's not a money movement or it's not a settlement or a disbursement. It's rather a messaging infrastructure or a messaging layer. It's just a telegram sort of a thing. You can just assume it to be the interbanking telegram, right? So that's one thing. And then what sort of cracks are there in the system in terms of the payment delays, in terms of the T+1, T+2, sort of the settlement delays for the disbursement, and the fee transparency, because many companies are afraid in this space, like, hey, you know what, we don't have the transparency around the pricing structure. We don't have, we still see issues in the markup fee. We still see issues in the the intermediate banking pricing, because each and every layer has a cut. So each and every banking, the intermediate banking would be taking some cut. And then the first wave of fintechs, like companies like Wise, the TransWise, erstwhile TransWise, and then PayPal, Ripple, and like these are some of the early challenges that got in. But it's just not the fintech and PSPs. A lot of banking institutions are getting into that. Visa, Mastercard, and like a lot of big players, like bigger commercial banking institutions like banking depositories and CBDCs. And central banks are also getting into that. So we'll talk about that. So this in a nutshell, like I'm going to talk about the blockchain and stablecoin technology and what's next in this space. Uh, okay. So in a nutshell, this is all we are going to talk about. These are what is the payment rail. So we see, I'm hoping everyone is able to see the screen, right? So we are in a we are in a space where the money movement is actually the big concern. In fact, we are moving close to 150 trillion as we speak, and Swift in itself is moving like close to 5 trillion per day. Like, so the volume or the scale is just humongous in this technology in the fintech space. And right now the payment delays are like it's taking close to about 1 to 5 days for the payments to reach. And blockchain typically takes about a fraction of seconds to a few minutes. That's kind of the latest innovation in this space. And stablecoin technology, of course, as I mentioned, many different players are coming into this, like Circle, Stripe, Coins, Bitso, like a lot of Latin American companies. And there is a lot of payment innovation that's happening in Thailand, like in PromptPay, in India with UPI, and of course, in China, Hong Kong, and called Embridge. So these are like some of the payment innovations that's happening across the world. A lot of companies are, evolving and innovating something new in this fintech. But it's just not about one thing that I want to kind of leave you folks or give a thought is just it's not about changing the UI, but it's also about changing the entire way of plumbing or the internal infrastructure and the payment platform in itself. So this is the old world. You folks might have been familiar with this one. You would have seen the sender's bank, the correspondent bank, and then the recipient bank, and how the money gets moved. From sender to recipient, sort of payer to pay. That's how the payment jargon terminologies would work. So from payer to pay, we do have a lot of like aggregated wallet. We do have custodial wallet. We have some escrow accounts. How are we going to do the collections, and how do we do the disbursements? So these are two big things that most of the payment companies are trying to solve for. And the key challenges of the problems, as you could see, 2 to 5 days, and then 5 to 10% of the fee. Let's say if you're transferring $200, you're going to end up spending $20 in just fee for the real-time payment using FedNow, Fedwire, RTP, ACH, and few other mechanisms. Like there are three hops. Say, imagine, like I would want you to kind of visualize. Imagine a seller is trying to like sell something, and the buyer is purchasing from say the US, right? And there are like at least a minimum of three hops that's happening. Say if the buyer is from US and the seller is from Brazil, there are at least like 2 to 3 hops that's happening between the banking institutions and the intermediate banking. So, and limited visibility around the fee structure, no real-time tracking. And is it going to like, does it mean Swift is, I mean, it's the end of the road for Swift? Is Swift not going to evolve? No, that's not the case. Swift is moving close to 5 trillion per day, as I said, and there are like 42 million plus messages. So Swift is just a messaging layer. It's definitely not moving the money in itself. It's not a money movement mechanism. It's just about the messaging. And you can observe a couple of key things here called Nostro and Vostro. These are nothing but the pre-funded accounts. So I mean, this to be a takeaway for you all folks that Nostro and Vostro are the key pre-funding accounts that most of the banking institutions use. And 2017, there was a payment innovation in Swift I mean, like some additional rules have been put in place. The existing MT 103 for the payment confirmation, 202 for the payment confirmation kind of receipts have been fine-tuned. There is end-to-end visibility and tracking for the financial auditing and reconciliation purposes for the reporting. And then the transparency around the fee structure, like the spread and the mid-market rate and all those transparency would be available. So these are like some first set of challenges. The first company that I would want to specifically highlight here, I mean, even though I worked for PayPal for close to 11 plus years, I would love to highlight Wise and the kind of the layer that they replaced. In fact, they replaced a lot of UI UX, and then they also replaced some of the plumbing layers when it comes to the mid-market. The mid-market rate transparency, that's a key win. That's a key innovation at that point in time in 2011. So they pool funds locally. That's one of the things. And right now, as we speak, Ripple, which is a stablecoin cryptocurrency company, this is being used as a settlement mechanism. This is trying to replace the Nostro and Vostro. Of course, like as you see, it could have gotten a lot of pushback from many of the regulators, and SEC put a lawsuit against Ripple. But Ripple is one of the bridging currencies or the cryptocurrencies that is evolving in this space. And the new rails, as we speak, these are emerging. Like most of these are domestic rails. Pix in Brazil is one of the best, I would say, in the industry at this point. The speed of the transaction speed is just like less than 10 seconds. And then UPI is one like where India is kind of moving close to 10 billion plus in the monthly transactions. And FedNow, FedWire, ACH, RTP, these are like some of the product innovations that are happening here in the US right in front of us. In fact, I was part of integrating some of those FedNow, FedWire, ACH, RTP, and a few other things in the startup that I work for. And of course, one key thing to look out for is this M-Bridge. This is going to be the multi-CBDC pilot in the central bank sort of digital currencies in the depositories world. Like this is something, I mean, it's just not about the regulators and the technology, but it's also about the social reforms, like sort of the geopolitical reforms that's evolving in this space. So this M-Bridge is something to look out for the next future, like for say 50 years down the line. And then blockchain and cryptocurrency. I kind of briefly touched about it, but then what it does is like it moves a fiat to, I mean, basically we call that in the financial jargon as on-ramp. We move the funds from fiat currency, which is say JPY or USD, to blockchain cryptocurrency. Like in this case, it's a stable coin. So in this stable coin, it could be either USDC for the circle issued one, USDT for the Tether issued one, or it could be USDB for the bridge issued one, which has been acquired by Stripe. So these stable coins then on-ramp would then be moved on to on-chain, like Solana, Ethereum, Base, and then Tempo. These are some of the on-chains of the network where the chains are being moved. And the interoperability between the chains is something that is fast evolving. A lot of companies like Lightning Network, Lightspark, and most of the players like Visa and bigger players like Visa and MasterCard are getting into this. MasterCard recently acquired BVNK, which is a middleware. And I'm going to show you a very cool, diagram. So this one, if you look at it, it's not as simple as it looks. Even though the money is moving in fraction of few seconds or minutes, there are like so many layers in between, very similar to the traditional banking system in the card world. In card, you might have heard about the card processing, like issuer, acquirer, processor, gateway. There are like umpteen number of layers, including the interchange plus fee. Very similar to that, I can, like here, we have fiat issuers, network, liquidity providers, custodial wallets, and then the compliance mechanism. Most of the companies use TRM labs or chain analysis. And then the middleware API. So this is where like most of the product innovation is happening. So in fact, I'm working on building something similar for one of the big banking institutions as we speak. And then wallet, Privy is one of the custodial wallets, and then the decentralized finance like Morpho, and then the RAM players, like which is very similar to the rail selection. Most of the companies are getting into the partner preferred rail selection as we speak at this point. It's just not the stablecoin rail, but the combination of, it's not about replacing stablecoin.
Hey, Sriram, I'm sorry to cut you off. Just wanted to be like respectful for everybody's time. So you have like one last minute to wrap up.
Yeah,
Uh,
I'm towards the end of the slide. In fact, the last evolution is around the CBDC and the future of the cross-border payments. And as I said, mBridge is something to look out for. 134 countries are, sort of exploring and piloting the CBDCs. And this is just a quick comparison. I just give you a second to quickly skim through. And yeah, so these are what's next in the space. It's just not the fintech, so it's kind of evolving along with the embedded finance in combination with the AI ML for the personalization of the user experience, along with the underbanked and the underserved corridors and the network interoperability between the chains. So all of these things combined together is going to shape up this fintech space. And I would leave you with that. So these are some of the key takeaways for you folks, and you might feel free to connect with me on LinkedIn in case if you have any further questions around it. I will pause here and thanks for the opportunity to present. Thank you.
Thank you so much, Sriram, for the great walkthrough for the payment rails. I just want to remind each and every speakers that it would be highly appreciated if you guys can stick to that 8-minute mark so that that attendees get a chance to like interact with you guys and then ask questions. So yeah, if you can like stick to that 8 minute, that would be highly appreciated. Our next speaker spent his days solving the problems that keeps the system running smoothly behind the scenes. Please welcome Sai Sandeep Koneti, Senior Technical Support Engineer at Microsoft, where he leads reliability engineering initiative across Power BI and SSRS, improving service availability from 99.5% to 99.95%. In his talk, What a Decade of Building System Taught Me About Reliability, Trust, and Design, he'll share lesson learned over 10 years of building and maintaining resilient systems. Over to you, Sandeep.
Hey, thank you, Nishi. Let me see. Some issues here. Okay.
Internet doesn't support us on the most important. It happens to everyone.
Yes. Yeah,
Mm,
I apologize.
You're good.
Let me try it on the screen here. Shoot me. It seems like I'm not able to share my screen at all.
Uh, Sandeep, should we move to our next speaker and probably you can like set it up? Yeah.
Yeah. Thank you.
Good. So the next one we have here is from someone who makes sure enterprise data is clean, trusted, and usable. Madhukar Dongala, the Senior Informatica MDM at the KeyCube Technologies. He's led the master data management implementation for organizations like Whataburger and Novet Health. In his talk, Metadata Lineage and Explainability, the Foundation of Responsible AI, he'll share why strong metadata and lineage practices are essential for building AI system we can actually trust. Take it away, Madhukar.
Hey everyone. Uh, I think you can see my screen, right?
Yes.
Yeah, my name is Madhukar. I have 14 years in industry. So where I worked with different technologies, and my most concentration is on data governance, as well as data management, as well as data lineage and everything. So today I'm going to present metadata lineage and expansibility, the foundation of responsible AI. So as artificial intelligence continues to grow and transform industries such as healthcare, finance, retail, manufacturing, and government organizations are increasingly relying on AI to make critical business decisions. So, however, the success of AI does not depend only on advanced algorithms or powerful computing resources. It depends primarily on the quality of the data and the trustworthiness of data and the governance of data, which is used to train these models. If AI learns from poor data quality, then therefore, building AI responsible AI requires more than creating intelligent models. So today in the agenda, I'll be discussing on these other topics like what are the responsible AI needs in data governance, and what is the context behind it, and what is the data lineage, and what is the foundation we use. So all those kind of things which are useful in building the successful AI data governance. So what is the trust the data. It's nothing. Before discussing the metadata and explainability, I want to give a brief introduction on what is kind of a importance of understanding of why trusted data is the foundation responsible for AI models. If the training data contains duplicate records or missing values, outdated information, so these problems will be arising in the data governance. That's why organizations invest heavily in the data governance. Trusted data ensures that AI predictions are accurate, consistent, and unbiased, which is creates an end-to-end traceability and moves across different systems. So that's why trusted data is the most important critical thing in every organization, which makes stronger decisions and making good return on investment of values. So the context behind the AI is metadata is often described as data about data, but in reality, it is much more than a complex description. Metadata provides the context that allows both human and AI systems to understand the meaning and what is the purpose and what is the ownership and who is the quality of data. And it defines what are the business terms and what are the security classifications and what are the data quality rules. All those things which are helpful in defining the metadata. So as you can see, a metadata is nothing but your customer ID becomes much more meaningful when metadata specifies that it's uniquely identifies each customer. So in this way, we'll define a metadata. So as you can consider, metadata is nothing but your tables, columns, or views, or whatever the systems and whatever the applications you are present in the system. All those can be considered as a metadata. And uh, then the data lineage. So this data lineage is nothing but once your metadata provides a meaningful to the data, the next step is understanding how this data travels from one system to other system, and what is the data lineage becomes extremely valuable. So data lineage documents every stage of the life cycle of data, beginning with what are the source systems such as databases or APIs or ETLs. So in this way, the data lineage creates a lineage between application and then integrating with data quality, and which makes as a data lineage. So this will understand where the data is originated and who are the persons responsible and who are the people needs to be taken care. All this kind of information is visible on the data lineage side. And the AI prediction, the role of AI, it predicts what is the correct and incorrect data. So that is the reason we are much dependent on the AI side. Then how the AI decisions will be understandable. So artificial intelligence models, especially deep algorithm models, operates based on the black boxes, meaning they produce predictions without explainable how these predictions were made. So while these models can achieve remarkable accuracy, organized cannot blindly trust decisions that cannot be explained. So explainability techniques helps user identify each variable on the final outcome. And basically, the line gives a local explanation for a single prediction, approximately the model with a simple interpretable and the need to justify, which is useful for the AI prediction data. So combining this, bringing metadata with the lineage and the explainability because they are complemented from one another through AI lifecycle. Metadata provide context by describing what the data means, where it belongs, and who is responsible for it. Whereas data lineage provides transparency by documenting every transformation and movement of data from source systems to AI predictions. So together, these three components establish trust, accountability, transparency, and governance. So this is a data lineage represents the construction history documenting every stage of the product. So, what is the enterprise AI architecture? A modern AI architecture integrates governance into every stage of the data lifecycle. So, rather than treating governance as an afterthought, data is collected from multiple sources, including transactional databases, streaming platforms, APIs, cloud storages, and external systems. Centralized governance layer manages metadata, business glossaries, and the data quality rules and the security classifications and compliance policies. So the lineage layer continuously tracks every movement and transformation of data, enabling an impactable where it is moving from and where it is loading from. So AI and machine learning models are then developed and used trusted governed data, reducing the likelihood of based inaccurate predictions. Finally, the layer identifies the model drift, uh, providing impenetrable explanations for every predictions. In this way, the AI lifecycle, rather than being induced after deployment. And what are the real world examples are? These are used in patient data. You can use it where the data is processed and where it is featured and what are the risk predictions. Metadata provides standardized definitions for every medical attribute and establish ownership responsibilities and validates the data quality. So in this way, like metadata lineage and explainability, which is used in the real world things in the predictions. So the to conclude this thing, like responsible AI is fundamentally built on responsible data rather than sophisticated algorithms and alone organization. They want trust. They want trustworthy AI and must invest in strong data governance by maintaining comprehensive metadata, and which creates a complete end-to-end lineage and robust explainability throughout the AI lifecycle. Metadata provides business and technical context lineage, ensures complete traceability and explainability. Together, these capabilities, AI continues to become part of everyday decision making organization that prioritize trusted data and will build more ethical, reliable, and successful AI system. The key message is I would like to everyone to remember today is simple. Responsible AI is not just about building smarter algorithms. It is about building smarter, governed, and trustworthy data ecosystems. Thank you.
Thank you, Madhukar. That was so important. And thank you so much for sharing your insight with us. I would like to open the floor to all the attendees. Are there any questions for Madhukar?
Thank you.
Awesome. Sandeep, I got your presentation. Should I try and see if I can share, and then probably you can just drive and let me know whenever we need to move to the next slide.
Yeah, that'll be great. Thank you so much.
Let's try that. Looks like I also might not be. Let's try this. Can you guys see the presentation?
Yeah.
Okay, awesome.
Thank you so much. Hey, hello, everyone. Thank you for this amazing opportunity here. I'm Sai Sandeep Koneti, a senior data and BI engineer at Microsoft. Over the past decade, I've had the opportunity to build and work on large-scale systems. And today, I want to share a few lessons throughout my experiences here, what has taught me about reliability, trust, and design. Right? You can go to the next slide, please. For the last 10 years, I worked in data engineering, business intelligence, analytics, and reliability engineering across multiple domains, healthcare, financial services, construction, and technology. Most of my career, I've been focused on helping organizations turn large volumes of data into meaningful insights, support critical business decisions, have the opportunity to work on wide range of projects, um, which turns meaningful data into insights for across the organizations and that scale and of users. Um, if you can go to the next slide. Um, when I started my career, I thought success in analytics was all about building dashboards, reports, and data pipelines. Those things are important, but over a period of time, I've learned that they're just part of the small story. The biggest lesson is the most valuable lesson is regarding the analytics platform is not necessarily the one with just the most features. It's the one people trust. It's the one what people trust, what you're building to them, what they are using, how reliable that is, and so on and so forth. If you could go to the next slide. Think about it this way, right? It doesn't matter how beautiful a dashboard is if the data is inaccurate. It doesn't really matter how advanced your analytics are if the system is unavailable during a very critical time where your business users are about to make a decision, anything along those lines. And it doesn't really matter how much data you have in your systems if your users doesn't have confidence in the results, right? That realized me how I changed my approach, how I move along on building these systems for my customers, internal users, and all the users who are using my data. If you could go to the next slide. Thank you. As I moved into larger enterprise environments and eventually into the role at Microsoft, I became increasingly focused on reliability, observability, and operation excellence. This combines everything what I have, dealt so far, all the organizations I've been working with to build solutions, deploy solutions at scale. Next slide, please. Today, I work on enterprise analytics and reporting platform used by organizations across the world. One of the challenges with system at this scale is the problems are really, really simple. A reporting issue might involve data pipelines, semantic model, infrastructure, authentication services, or application dependencies. Because of this complexity, we focus heavily on creating dashboard diagnostics. Um, which are really, really helpful in developing repeatable troubleshooting methodologies. The goal wasn't just to fix the problems faster. The goal was to determine and understand why the problems occurred in the first place, right? And then how we can prevent this from happening, either through logs, through repeated troubleshooting techniques, so on and so forth. Next slide, please. That shift my focus from reactive support to a proactive reliability engineering, which had a significant impact on the way how we look at things at Microsoft or even at any organization at scale. We improved platform availability, reduce issue resolution times, and helped. What I found was more interesting is how reliability directly affects the business user outcomes. When analytic systems are reliable, organization makes decisions faster, teams spend less amount of time validating the data and moving things accordingly as fast as they could. And also engineers spend less time firefighting and more time innovating things at scale, right? Which can be very helpful for the users. Next slide, please. As many of you work on the hackathon projects, I think it's the more holistic idea is especially relevant here. I mean, innovation is moving along incredibly faster, but the same principles still apply. Ask yourself, can the users trust the data? Can the system work at scale? Can you understand what's happening and something doesn't go work as expected? Can the solution deliver a value as an adoption grows? Those questions often determine whether a project remains at a prototype or becomes something that people depend on each and every day, which can also be deployed for enterprise customers. Next slide, please. Another lesson I have learned throughout my career was how important is sharing the knowledge. I have had the opportunity to mentor more than 50 engineers across different countries. One thing I have consistently seen is how strong the engineering cultures are really, really helpful. Like knowledge sharing, how well we can work together, who are coming from different backgrounds, experiences, and perspectives to solve problems collaboratively. Next slide, please. Close it out. If there is one takeaway I would like to leave with you guys, it's the technology, the value it creates, and when people trust it, right? Whether you are building a dashboard, a data platform, an AI solution, or a startup, the focus only not only on the innovation, but also on the reliability, scalability, and the user trust. Those are the qualities that transform interesting ideas into long-lasting impact. Once again, thank you for the opportunity here. I'm looking forward to connecting with you all.
Awesome. Thank you so much for those insightful talk. Any questions for Sandeep? I take that as a no. Before we move on to our next speaker, do we have Palak here by any chance? Uh, Palak, I would request you to join the judging room for the presentation. They are waiting for you.
Hello, ma'am. Are you calling for Palak Renayat?
Yeah, I think so.
Ma'am, actually, I am from her team, and on the behalf of her, I will give the presentation of our project.
Okay,
Is it
awesome.
allowed?
Yeah, can you join the judging room? I think so. They are waiting for your team.
Okay, ma'am. Okay.
Awesome. Let's move on to our next speaker who has spent his career figuring out where revenue and engineering meet. So please welcome Sai Charan Oblidian, who is a staff engineering manager at Geico, where he drives initiatives and mentorship, governance, and AI driven observability. He's here to talk numbers, specifically how to measure whether a AI tool can actually be making engineering team faster. In his talk, AI effectiveness calculation for the engineers. So let's all welcome Sai Charan.
Thank you. Hope you guys can hear me okay, correct?
Yep.
Okay, let me share my screen. So yeah, so my name is Sai. So I am right now working as a staff engineering manager at Geico. And previously I used to work for Meta and two other startups. So recently came to the management field. Previously I was a staff engineer and lead for a couple of other startups and including Meta as well. So in this presentation, I would like to talk how effectively, how to basically measure an effectiveness, right? How an engineer is going to use the cursor and how can we actually draw the metrics and say if a specific engineer is actually making use of these tools effectively or not, right? In their like day-to-day development. So this is just the version one. So we are, I mean, I'm still figuring out a lot of things. and what metrics to add, what metrics to remove, and all that stuff. But the goal is basically to measure the effectiveness, not just the activity, right? Because actually it's alone cannot prove the effectiveness of an engineer, right? So yeah, with that, let me jump in. So why this matters, right? As we know, the AI usage is increasing across many teams, many orgs, many companies, and everything. So so that's why, like, if you're spending more money on AI, that doesn't mean that you are using the AI effectively, right? So you need to have a consistent, way, like how actually engineers use these AI tools, right? How they prompt, what is the quality of their prompt? Does it have the all the context that is needed? Are you giving the enough context to it? Are you asking the right questions? Are you upfront giving the prompt, the result that you want, how you want to how you want you to look at the result, right? And whether it is like cost effective or not, right? And improves with it should deliver with quality and work from all that, right? So basically, it's a simple framework to access AI effectiveness in practice. This is what I'm kind of moving towards. So right now, yes, the current inputs. See, right now, existing metrics in general, like any company will look at, oh, number of prompts. What is their monthly usage in dollar? I mean, they will look at, like, if you spend more dollars or more tokens, then you are using it effectively, which is the wrong way of looking at it, right? And prompt quality, the number of active usage. I mean, this itself is not enough. You have to uh, use a little bit more, like, these metrics are actually only used for adoption, activity, prompting behavior, and cost, right? But they do not completely show whether you are really using it effectively or not, right? So, what I came up with, obviously, the prompt count, you will take a look at the prompt count, how many prompts, monthly spend, and prompt quality, and how actively that you are using in your org or in your team, right? Because every org and every team are pushing engineers to make use of the AI in every task, whether it is design, research, development, testing, automation, including sending emails, including sending Slack messages, right? Everything in general, right? So we are pushing every engineer to do this. So that's why we'll have to know the prompt count, monthly spend, prompt quality, active usage days, and also, and if you get a response from an AI, like for example, this specific presentation is only for Cursor. But I know a couple of teams use Cursor and Claude combination, or Claude alone, or Open Code, or Gemini, Copilot, right? It doesn't matter which tool that you use, but if it is, this presentation is only for Cursor, right? Just the version V1 what I have. So you have to also look at what acceptance rate, like, did you really accept whatever the Cursor gave you, right? For a specific code prompt, for example, right? Or do you need to rework? What is the correction rate? So these two metrics are also important in order to find the AI effectiveness, right? Because they connect AI usage to the engineering value. They help to distinguish productive usage from the tool crash, right? I will show you how I actually came up with a formula for to calculate this AI effectiveness, but I'm going to show you these dimensions, what scoring dimensions that we have that I came up with. So adoption and usage, prompt quality and task framing, like whether did you provide the clarity, specificity, context, constraints, does it have the context, and also workflow effectiveness, efficient use of sessions and continuity of the context. These are very important as you'll be consuming more tokens, which in fact affect the cost of the cost of the specific ask. And human oversight and output validation, like you'll have to verify, re-verify, improve AI output, and quality, risk, and ownership, accountability for the code quality. But again, let's here your cursor or Claude is not responsible at the end of the day. They are going to help you to move fast, but they are not responsible for whatever they give, which means a human should be responsible for it. That's why you will have to verify, review, right, and then get what you need from that specific tool. So yeah. So the scoring mode that I have is, I kind of score in level one, level like four levels basically. So you can't call an engineer as emerging when they actually, just have some basic awareness or initial usage. Practicing is regular usage is growing competency, and fluent is effectively integration into daily work. But expert usage with team impact and best practice development. So kind of gave it to four different levels to score an engineer. But are we going to use this scoring to really at the time of performance reviews? Not necessarily, because it's not really tied. You don't need to tie this to a performance review, right? But you can actually gauge an engineer with this type of scoring and help them evolve in using the AI tools effectively, right? So the formula that I kind of came up with is like 20% of this adoption usage, right, and 25 prompt quality, and then workflow effectiveness, which is 20%, and then validation oversight, which is 20, and then the scholarship, which is like overall AI effectiveness scoring, right? So yeah, not complicated one. So I think I still need to do a little bit more research on this, but the way that you can score an engineer is what I have like 20% on the eruption usage, and the remaining 25% is on the prompt quality and etc. Now, what so this is, see, as I said, it is just the AI effectiveness score, not a performance score. So you cannot tie this to a performance for any engineer, right? So because the AI can make mistakes, even if you give every single context, even if you follow every single prompt quality context, the workflow effectiveness and everything, even if you're for an L4, AI can still make mistakes because it will just give you what it knows, right? The specific model, what you train that model on. So that's why you cannot really tie that to a performance, right? So that's why I'm going to call that as an AI effectiveness score. But is alone going to help engineers to increase their AI usage, the prompt quality, and user product competition is for coaching, not for scoring. So this is I'm going to start with only cursor and then verify over time. As I said, multiple companies, multiple even teams. Few teams has Claude, few teams has Cursor, few teams has open code, like whatnot. Right. So yeah, with that, this is just the version we want, what I came up with. Um, and I'm done. That's it. I'll take any questions if you have.
Thank you, Saicharan, for the practical breakdown. Up next, we have Rang Ganesh Singh, who is a principal software engineer, also a tech lead at Fidelity Investment, working on the architecture behind the Tier 1 financial trading systems. In his talk, The Autonomous Ecosystem, he'll explore the shift from legacy batch processing to real time AI native trading ecosystem. Let's welcome Rang Ganesh.
Hello, everyone. Do you want to share my screen, Manisha?
Go ahead and share your screen, yeah.
You able to see my screen?
Yes.
Thank you. Hey, hi, this is Ran Ganesh Singh. So I'm going to talk about the AI and future of trade architecture. Sorry. So when we talk about AI in fintech at events like this, the conversation always defaults to consumer layer, right? Robo advisors or retail chatbots. But today, I want to look past the glass. So we are going to talk about the true frontier of AI in finance, which is basically the architectural plumbing of critical applications and how we migrate from complex legacy systems to cloud native self-healing platforms. Most consumers think finance happens instantly. That's because their mobile app updates in real time. But as engineers, we know the reality, right? Beneath the surface, especially the finance industry, is still heavily reliant on legacy batch processing systems, trying desperately to cope up with the volumes and all that. So the real challenge we face is not just building a clever predictive model, it's about architecture. How do you deploy AI into a critical trade processing environment where a single failed trade settlement cascades into a massive financial liability? So I'm picking middle office here because of my experience with middle office. So the middle office has been the historically the bottleneck of financial trading. Uh, the front office is good; it executes trades in microseconds. But the middle office is a place where the heavy lifting of trade allocation, reconciliation, and all the settlement happens. And we want to fundamentally review this, rewire this layer, and we are replacing the current robust rules-based engines with the new machine learning models that predict trade breaks before they occur, based on the data patterns, historical patterns, etc. And the ultimate goal for us is to have a zero-touch settlement trade life cycle, which deserves a manual intervention for only for highly volatile strategic decisions. So I'm going to talk about event-driven infrastructure. So you cannot build a real-time AI-driven financial system on top of legacy messaging queues or all the legacy databases, all of them. In my experience, where I led the redesign of the messaging architecture, managing pivot from traditional platforms like ActiveMQ or RabbitMQ to distributed event models like Kafka is a non-negotiable prerequisite. And when your middle office trade processing application needs to handle millions of daily messages, we need high throughput, low latency infrastructure that only distributed event logs can provide. And this is kind of a central nervous system, I would say. Now, here is the catch. When you successfully migrate to Kafka and optimize your, partitioning or strategies, you will solve the latency problem. But when you accelerate the trade processing or trade settlement lifecycle to some millisecond cycles, you are also accelerating the speed at which systematic anomalies and the threats can cascade through your architecture. So if a malicious payload is moving through an event system design in real time, a reactive security audit is useless. The damage is done before the alert is triggered. So your security layer must be as dynamic as your infrastructure. That's a caveat with finance. So this is where Gen AI or generative AI shifts from a buzzword to a critical defensive engineering tool. Because our event-driven architecture is capturing every granular state change, we can feed that continuous simulation or continuous context into Gen AI models. And we use Gen AI for autonomous threat modeling. Instead of writing static rules for yesterday's attack, these models will simulate complex attack vectors against our legacy trade settlement flows. So which gives a flexibility to dynamically deploy, this defense mechanism before the actual failure occurs. So especially, I'm talking both in terms of front office and middle office, right? So briefly looking at the front office, algorithmic trading is entering. We all see that the robo advisory trading and algorithmic trading is using the multi-agent AI ecosystems now. And we are talking about here swarm intelligence, basically distributed networks of specialized AI agents working in tandem. One agent parses real-time regulatory filings, another analyzes regulatory data streams, and the third executes the actual trade strategy. So by utilizing reinforcement learning, this system continuously adjusts their parameters and data source priority based on the current market conditions, all while maintaining the strict audit trails required for compliance. So to close, the future of smart finance is not just about building a smarter or clever algorithm. It is about building the resilient, scalable infrastructure that allows that algorithm to survive in a high stake, high volume environments. The institutions that win the next decade will be the ones that successfully migrate this complex legacy architecture to AI native platforms, considering all of the factors I mentioned. Thank you.
Thank you, Ranganesh, for the fascinating look ahead. Any questions? Awesome. Closing out today's speaker lineup is we have someone who quite literally keeps the internet fast. Mayank Dwivedi, Senior Engineering Manager at Salesforce. He led the migration of Salesforce Lightning CDN to AWS CloudFront, saving over more than 1.8 million annually. In his talk, AI Native Cyber Defense Building Autonomous Security at Internet Scale, he'll share how AI is reshaping the future of cybersecurity at scale. Over to you, Mayank.
Thank you, Manushi, and thank you for Wave Hackathon to for giving me this opportunity to talk here. And let me share my screen presentation. And thank you for the kind words, Manushi. I want to reintroduce myself. I am Mayank. I'm a senior engineering manager at Salesforce. I've been in this industry for about 14 years. I manage CDN and large scale platform teams here at Salesforce. Part of it is also edge security. So my topic today would be AI native cyber defense. Like how can we build an autonomous security at internet scale? Um, I believe you're all able to see my screen. If not, let me know. Um, yeah. So imagine it's like 2 a.m. in the morning, and you get your systems alerting you that there has been an AI powered botnet attacking your system. It's probing your APIs. It's solving the captchas. It's able to adapt to all your rate limits. It's attacking. It's able to like bypass all your defenses. Like because it is able. It's an AI thing. It's able to adapt faster than you can, and then by the time that your human security engineer is brought in the loop, the attack has evolved and new services done. So, like, how do we defend our systems that like change faster than the humans can respond? That's the question that we all have to answer today at enterprise scale. And why traditional security isn't enough, right? Like right now, like everything is configured for human attackers. There are static rules. There are like manual response in your pipelines. Somebody has to review the request, and like the amount of security threats that the security engineers get these days is like huge and humongous so much. The analyst cannot respond in that uh, with speed and velocity, like what is demanded, right? There are also there's so many alerts that are being generated. It's very hard to filter out like what is the actual signal and what is noise, right? So there's tons of things which is has to evolve to adapt to this new AI threat that we have, right? The attack velocity exceeds the human reaction time, and defense must be re-architected from the ground up. Talking about the threat, they uh, we're noticing they're AI generated phishing scenarios here where hyper personalized lures at massive scale, customized for your own liking, personalized about what you actually want to. Um, I'm sorry, this is. Are you able to see my screen?
I can see your screen. Yeah.
Apologies. System. All right. So yeah, they're customized to personalized to lure you. For example, if you are interested in say a team of soccer, so it will be luring you hey, we have a ticket for free. So all these personalized recommendations are coming your way, and it's very hard to kind of detect and separate them from actual emails, and it is getting serious these days. There are also a lot of attempts, millions of attempts every day to change credential stuff, and they're changing the credentials again and again, and then they're trying to break into your systems. Like deep fake is reality, AI synthesized voices that matches you and the real human beings that you know, and very difficult to detect. They're able to bypass the security verification as well. So they're no longer driven by human. They're not scripted. They change, they adapt to your threat models, and then they're able to self-improve, which is a real threat in today's landscape. So the answer to that is to build security at each and every layer of your architecture. um, this slide shows how different layers in your architecture can help and a need an uplift with regards to security to make sure we are ready for this new changing landscape of AI threats. The very first layer, as you see from top to down, this actually represents traffic from left to right in your system, where the very first layer is edge. That is the CDN layer, which includes your WAF rules, bot management, rate limits, and not just static rules. These should be smart enough to adapt and quickly based on data, able to recognize bots, their fingerprints, the attack patterns, signatures. Everything should happen real time, and that's the first layer of security. Your API gateway is no longer can be just the request forwarders. They need to have intelligence as well. They should be able to understand the load, the request patterns. Is it suddenly coming from some new continent? Is this request coming from why is a sudden spike in from this particular endpoint? And this is what is needs to be done at every single layer. You have identity and access layer. We should kind of able to figure out um, what device this is. What is the fingerprint of the device? Is it a real device? Is it a look at the access patterns? Is the login real? All these how confident are we with the authorization and um, the access. So that's very crucial layer which we need to include. And then telemetry. We all need to have enough telemetry in our system that kind of pulls in data from all these layers and is giving to the next layer, which is the threat intelligence, which is able to identify, okay, how confident are we that this is a real threat versus a normal traffic pattern. This is very crucial layer because it would help you figure out whether this is a real threat or is the real traffic. So um, uh, and all of this is combined into your data platform. All of this converges into a layer of security data platform where all these logs, all these insights from the other layers are brought in. When you became and then they're analyzed by AI, by humans to generate some patterns and more and give more insights to these layers again. So this it becomes a platform layer where you're collecting everything, you're generating the insights, and then feeding it back. This feedback loop is also important, where each and every layer stays updated with the current things based on your system, based on your enterprise, and then which is actually the bonding thing for the AI reasoning layer. It's able to reason. Is this based on all this data that I have seen so far? It's able to reason whether this should be, whether this is attack, or it's a normal uh, usual traffic pattern. So which, and all of this should be fed to like autonomous policy engine, meaning that based on all this data, all this reasoning that we have collected so far, there should be an engine which should be able to take an action, uh, 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 take an action uh, on like blocking this attack. So it should be able to either block, rate limit, send captchas, or like any policy that enforce based on the kind of threat. So this all needs to be built up like top down, so that you are able to react faster. And at the end, like all of these need human approval. So all this data, policies that we're enforcing should be approved by human in the lead, just to like and set in the engine. It's not like you're approving each and every time, but you are reviewing all these policies at a cadence and making sure that everything is set correctly, so that there's always human in the loop to verify that things are functioning properly. So like detect, reason, and then enforce. These are the three big structure of the security right now, and any enterprise today needs to have this built in to handle the threat. Uh, all like companies are evolving towards creating specific agents for security detection agent. It's able to detect any anomaly across all traffic streams. Threat intel agent is able to get all these feeds and correlate with internet in like context that you have built from your previous attacks and telemetry. Investigation agent is able to get the RCAs faster, get the attack chain, how it is, how was the attack, and figure it out faster than humans can. Policy agent can generate and validate rule changes like block, rate limit, remediation. Can I contain this attack? Can I how can we limit this to a specific set of users when it comes to if you're not able to block it? And then make sure that we are compliant with all these audit trails and regulatory alignment continuously with like why was this traffic blocked, and what we have all the fingerprinting and audit trail prove our customers that this is the reason why. So like all these agents need to be built up where you are able to like enforce security for your system. Like if you take an example of, I'll just showcase a real world like scenario here. You have a DDoS attack. Like there's a machine learning model attacking your like let's say if there's like AI attacking your system, you have built in that intelligent DDoS layer at the edge where it is able to detect that there's a sudden spike in the request volume. It is faster than the uh, normal pattern. There's then if the attackers are smart enough to uh, uh, keep the request volume lower than the like traditional DDoS detection volumes, the API layer comes in and it's able to figure out like is this like a bot smart enough to evade my DDoS protection and still be able to abuse my endpoints by keeping simple human-like timing. That should be read by the API defense layer. WAF rules also should be like adapt. It generates the context available. Okay, this particular sample attack looks like it's triggering this endpoint. It has got this payload, and then we can tweak the WAF in real time. It should be able to detect and log those rules in. Each login attempt that you make is we look at the score. How confident are we that this is a real login? Is it not a credential stuffing attack? Like looking at the IPs where it is coming from, device fingerprinting, what is the velocity of login, and other feedback loops that we have built in the system previously. And then lastly, like you have the incident triage, where you can look at the full attack timeline in minutes. Like it should not be like where like if it were human, it would take at least days to figure out the whole thing. But the agent can help you with like drawing the timeline and making that data available for any analyst to like kind of like take appropriate action. So like uh, and lastly, uh, it should all be autonomous, but accountable. Like without governance, autonomy can be like a liable action, right? So every action must be explainable, auditable, and reversible. So you need to make sure that there's always human in loop, where high impact decisions are evaluated and discussed um, uh, before an action is taken, or like we need to review all those policies that are being like enforced. Every recommendation that the agents or the AI is making should include a clear rationale, like why are we why it is recommending this particular agent action. All these actions that we enforce should be able to be a rollback. So that if it takes the wrong decisions, should be a human should be able to reverse it out. And all the policy should be built around enough guardrails, so the AI cannot uh, step ahead and step over you to take an action which is not good for your system or your enterprise. So that's the reasoning, that's the responsibility that we need to build in our AI system, like making sure that it's all accountable, and we are the ones who are making sure we should make sure that we are adding enough governance in all our policies to make sure this goes through. Um, so next, so typically like security operation centers involve like human analysts sitting in a war room trying to see what's happening in the system. Um, what we really need to make is like the self-healing software, where it can detect, isolate, and recover from the compromise like autonomously. And we have specialized agents, as I said earlier, kind of which are able to talk to each other and get all this information and build that defensive layer, take an action, and then once an action is taken, they can have that feedback loop where whatever happens, they have live data, different strategies that can like compound over time. All of that is like fed into your machines for future actions. So the future of security is a partnership, like where you have agents who are handling speed, millisecond detection, investigations, humans who are providing judgment, context, ethics, guardrails, accountability, things which machine can't do. So together, both human and agents would shape the future of security. More reliance on agents or AI for speed and detection and more information, and human provide that human in the loop model where they provide the exact judgment. Thank you. That would be it. Any questions?
I think, yeah. Thanks, Meng. Really appreciate your enlightening talk. That brings us to the end of our speaker session. Thank you so much to all our speakers for taking the time to join us today and share your knowledge, experience, and perspective with everyone here. We truly appreciate it. Now that our speaker session has wrapped up, it's time for a fun little shift in gears. Turns out some of the brilliant minds in our community didn't stop at writing code. They went ahead and wrote entire books. So let's give a warm welcome to three authors who turned their expertise into published work. Let's get into it. Let's kick things off with an author who basically asks the question every business secretly fears. Are we actually making decisions or just guessing confidently? Please welcome Ankush Sanjay Mahajan, the author of Decision First Responses Enterprises, Transforming Businesses Through Intelligent Data Systems. Take it away, Ankush. Tell us more about your book.
Hey, hi everyone. I'm going to share my screen. Is that fine?
Yep.
Uh, Everyone able to see that?
Yes.
Okay. So a few things about myself over here. This is my book, Decision First: Enterprise Transforming Business Through Intelligent Data. And just a minute. Okay. Uh, so, yeah. So, good afternoon, everyone. Thank you all for being here today, and it's a pleasure of mine to introduce my book. This book is the result of my passion for data analytics, artificial intelligence, enterprise systems, and all these years of experience. My goal was to bridge the gap between academic concepts and real-world applications. Few things about me. I am 10 plus years. I hold 10 plus years of experience in this field. I'm an expert in AI, decision making, data analysis, and business intelligence. Uh, let's move on to the next slide. So, why I wrote this book and how does this work basically? So, organizations today generate enormous amounts of data. Every click you do, every thing you buy, every site you visit is another data point, and that gets recorded. However, many companies still struggle to convert the data into better business decisions. I noticed that most books focus on technologies such as databases, cloud platforms, machine learnings, and analytics independently. Uh, uh, but very few explain how all these technologies come together to support better business decisions. Thus, this inspired me to write the book that puts decision making, not data, at the center of the enterprise transformation. Mm. Explaining the process, we should first identify what decisions are most important for any given enterprise or the data that lies ahead of us, how to use it to make better decisions rather than just to work on the data and then go for making a decision. The book is organized in such a fashion that we begin with the foundations of the decision intelligence. Then we explore enterprise data architecture, cloud platforms, governance, and intelligent automation. The book also includes in industry focused chapters covering supply chains. Let me just move to the next one. Sorry. Yeah. Yes. Yeah, the book will give you a overview of supply chain analytics, credit card fraud analytics, banking decision systems, and energy analytics. And finally, I've concluded with some autonomous AI-driven enterprise and the future of intelligent organizations. Who is this book for basically? So this book is basically intended for a broad audience. It holds value for university students, researchers, business analysts, data analysts, enterprise architects, and digital transformation leaders. Whether you come from academia or industry, the concepts are designed to be practical and immediately applicable. My key message here is, if there is one message I want readers to remember, it is that data alone does not create value. Better decisions create value. Uh, and like artificial intelligence, machine learning, cloud computing, all these comprise together for decision making will get you the results that you desire. But their purpose is to help people make faster, smarter, and more responsible decisions. When organizations become decision first, they become more resilient, more innovative, and better prepared for the future. Yeah. As for me, the future belongs to the organizations that will make better decisions, not those that simply collect more data. I sincerely hope this book becomes a useful resource for students, researchers, and professionals who want to understand the next evolution of enterprise intelligence. Thank you all for your support in this journey from mentors, my colleagues, my family, and friends. Thank you all for attending today's book presentation. I look forward for the questions and feedback.
I think we should be good, Ramesh.
Oh, okay. Thank you so much.
Yeah. Our next author has basically written How to AI Without Losing Your Mind. Manual for small teams. No fluff, no jargon, overload, just practical wisdom packed into pages. Please welcome Abhilash Pakalapati, the author of Making Work Easier with Modern AI Tools, a practical guide for small teams. Over to you, Abhilash.
Thank you, Abhilash. Let me share my screen. Okay, can you see my screen?
Yes.
Thank you. Good morning, everyone, and thank you, Wave Hackathon, for inviting me to share uh, my work today here. So, I am here today to share a simple guide that helps small teams. Like before writing this book, I was thinking like with the knowledge or experience or skills I have, how can I contribute to the set of people uh, which takes longer time for them to go over entire process and implement within their area. So that's when I have this thought to focus on the smaller teams. So the title of my book is Making Work Easier with Modern AI Tools. Uh, so which will be benefitable for the small teams. And if we see right now in the AI era, most of the tech companies, large enterprises are focused on how to spend millions of dollars and get the licenses for almost all the available large language models and give the licenses to the employees in the enterprises. But it doesn't work for the small teams to go and get the licenses for all the available LLMs and start working on those based on their uh, specialization. So the reality is that the major enterprise setups do not work for the small startups. So they focus on enterprise to enterprise, where they can where they focus on build their large language models, which require like large tokens to be consumed. And these small teams cannot afford those set of teams to hire or onboard, uh, and they do not have those engineering experts specialized for this usage of the AI. So that's why I wrote this book specifically to bridge that gap. And I wanted to give the smaller team a highly practical step by step plan to make AI integrated within their manual workflows, which they have been repeatedly doing without breaking their bank. And yeah, so coming to me on my background, I am a senior AI and consultant, uh, currently working as a senior AI consultant with one of the large mortgage federal client. And during my career, I have spent a lot of time working with the mortgage projects, fixing the messy data systems, and turning slow manual work into smooth and automated pipelines, and sending those
optimized federal reports to FHFA. So, working with the stakeholders of these federal companies on these critical reports and building these pipelines taught me in the first hand about the data safety, the verification rules while building and generating those reports, and few non-negotiable elements. And throughout my career working with these federal clients, I have noticed a major problem in the recent a couple of years when we started working with the AI. So these advanced AI concepts sound amazing, but they're often too complicated when we start working on the reports or everyday use, getting that enhanced reports, which needs to be sent weekly or monthly or quarterly basis to the federal stakeholders. So my main goal within this book is turn them into the easy time-saving steps for small teams, which they can use in a everyday work for making the better decisions. So yeah, this is the cover of my book, and yeah. So what brought me to completely go and uh, build and draft this book, having multiple iterations and finally coming to the publication of this. So I notice I work with a few small teams where my friends are running, and so I observed like when they were trying to adopt the AI and get these licenses and go and automate their existing manual work or day-to-day repetitive work, uh, we have been hearing everywhere right now, like we have been consumed all the tokens uh, almost as early as possible. So the reason why even this happens in the large enterprises, so the reason why we are consuming all the token limit is like we are considering these AI models as a standard Google search, asking a simple question or an answer assistant. Like in a single line, we go and provide as much as context possible. Like if we need to enhance or do some calculations for a spreadsheet and we we over provide the information and we come to the token consumption. And in the reality, asking model to do many things end to end in the same thread or with the same agent. So there will be a lot of missed details, a lot of wasting money on those tokens. So let me dive into the key themes which I have covered in the book. Like the core philosophy of this book is built on three very simple basic principles, like what AI does and what AI answers. So instead of just asking AI for an advice or templates, we build a setup where it actually runs the task from start and, for example, instead of asking AI how to clean a complete spreadsheet, uh, you build a pipeline where AI automatically catches the duplicates, fix those errors, or replace with the filters we applied and flags the bad data before a human or uh, the business opens the file. And the other theme I covered within the book is like managing the context. Like the biggest problem with AI currently is not the its capability or maths, what it can do. Like it's how we feed the information. So this book teaches to give a clear boundaries which we set initially, uh, explicitly defining the technology and restricted reference guides, so it stays perfectly on track, which doesn't make things up. To explain the technology, we will have the .md files when we are working with the agents, so that we don't want in the every prompt or in every new chart we go and mention the terms or the any conditions we need. And the third theme, which is required, is the human checkpoint when we are integrating this AI process. So I think my in the previous session, Mayank, yeah. So I saw a slide where he was talking about autonomy without governance is a liability. That's true in everywhere, either enterprise or our personal work when we are working with cloud code or codecs or other language models. So AI does the heavy lifting and data storing and fast typing, but human intervene expert always checks the final results for quality, context, and approval. So these are the few themes which I have described in the book. And the intended audience for this book, I wrote especially learning about the problems which I have read in the Reddit threads or in the Twitter on feedback I got from few of my friends who are running their own business and their daily pain points. So I narrowed down and focused on few of the small teams like small scale businesses and how educational institutions who don't have the tech experts and the small tech teams who has to go over their budget allocated for them and not overspend on the AI. So yeah, I was completely focusing on these business areas. And if I go little bit depth into the book in a few areas, like so I have outlined in one of the chapter about the agent workflows, like when we force a single AI model to manage planning, writing, or self-checking and verifying the results in a single chart window or in a uh, uh, single agent managing all these requests, its memory context starts to fail rapidly and it get confused. Even we will face when we are using Gemini or OpenAI in a single thread or a single chart, we have continuously trying to have a conversation on a topic. Even though it's a one topic, when the thread got increased, accuracy will decrease. So in this book, I shared like few formulas like addressing these and having correct way or right way of implementing these AI models, uh, how much they can save in the sense of time or money or uh, just all operational savings. So by making this AI focus on just one simple task at a time or one step exclusively to check for some empty rows, you get some completely reliable results, remove the cognitive noise, save massive amounts of money on this token costs. And coming to a few other ideas which I have outlined in this book, it gives like the step-by-step in detail blueprints for these three areas. Like for example, I have a founder who runs a survey business. He have been trying, or their team have been trying to integrate this AI process into their existing business workflow from past 2 years. Uh, they have been still working, but they already spent a lot of money on that, and their tokens have been exhausted. So I worked with them, learned their process, and started advising them what needs to be done and how. And I generalized that and uh, s- uh, made it helpful for other small business teams, how they can integrate and save their operational expenses and all. So yeah, and coming to the end of this slide, like using the AI successfully isn't about like buying the most expensive model we have available or allocating a massive engineering budget. Like it's simply about deep diving into the each and every action or every flow we have within uh, our within our project or workflow we had, and trying to see what we can, the way how we can automate that and streamline that in different areas so that they have a good end-to-end integration of this AI and have the human overview or expert uh, reviewing the results. And this book ends with like a clear roadmap where these businesses or teams or the institutions can adopt this in 3 to 4 months, going over these and phase by phase and building their confidence with the easy tasks first they have on their plate and scaling up safely in their operations. Yeah, this is all about my book, which is already published and available in the Amazon and Google Books. Yep, that's all I had for today. Thank you so much for giving this opportunity.
Thanks, Abhilash. Does anyone has any questions? Thank you. I think we're good. Um, Closing out on our book showcase is an author who's basically peeking a few years into the future and reporting back. Please welcome Sheetal Tatia, author of The Autonomous Data Future, Architecting Intelligent Data Platforms, Real-Time Analytics, and Agentic AI Systems for Next-Gen Enterprises. Welcome, Sheetal. Can you tell us more? Yeah.
Hey, thank you, Wave Hackathon. Thank you, everyone, for joining today. Hold on, let me check my. I'm not able to show. Are you able to see me, guys?
No, actually, we're only able to see your background.
Okay. Let me. Camera is not turning on.
That should be fine. Sheetal, if you can't, like, that's fine. We can continue. Can share your screen. Yeah.
Yeah, that's fine. And let's continue. Yeah. Let me share my screen. I will go present. Everyone. So thank you for being here. I'm Sheetal. I'm excited to share my book, The Autonomous Data Future, which is available on Amazon Kindle right now. So you guys can go ahead and purchase and read about it more. I'll just give a quick overview of what I have um, written in the book. So the book is centered on three major ideas like the intelligent data platforms, real-time analytics, and agentic AI systems. This all three themes together reflect how data architecture is evolving from the traditional support systems into something which is more adaptive, responsive, and becoming intelligent. Uh, so before we proceed, I'll just give a brief intro of myself. I'm the author of this book. Uh, I've been working in data and leading all the data and AI platform for last 14 years. I have experience in data engineering, data warehousing, and AI-driven enterprise solutions. I've been a consultant. I've been partnering with a lot of different clients like Google, Stanford are primarily my clients. I've good experience in supply chain, financial services. I'm currently working a lot in like the data center domains, building like Google is doing a lot of new data centers. So working in that domain, I have good knowledge on that. So my work is primarily focused in building scalable data platforms, analytic systems, and recently like the Gen AI and agentic solutions for the clients. Moving into the theme, I would like to give a short overview of what my book is related to. The theme of the book is uh, the first thing is the first is the intelligent data platforms. The idea that the data system need to be designed not just for storage and movement, but for adaptability, governance, observability, and the scale. The second theme is the real-time analytics, which is about helping organizations make faster and more informed decisions. The third is the agentic AI system, where AI moves beyond passive analysis and starts participating more actively in validations, insight generations, and workflow supports. So the book is intended for all the data engineers, the architects, the analytic professionals, the AI practitioners, and the technology leaders who are practical perspective on building modern future-ready systems. Plus, a lot of students can also learn how the real world uh, large scale data architecture works, right? So it's useful for a lot of audiences, I would say. So moving on to the key chapters of my book. So there I have broken down the book into 8 chapters. The first is the modern data stack, where it covers different components and patterns that from today's data ecosystem, like from ingestion, storage, processing, serving, cataloging, and analytics. It flags common bottlenecks like latency, fragmentations, and provides trade-off between turnkey cloud services and custom stacks. So key takeaway would be like treat the stack as a set of capabilities and design it for the change, not just for the current needs. So like given now the AI is evolving so fast, right? So we need to focus on what your stack can provide you what capabilities, right? So the moving on to the next chapter, it's all about like data intelligence at a scale. So this chapter covers more of like the techniques and the patterns to scale your to scale the data intelligence, including like embeddings and vector search and the modeling and other things. It also covers the governance and observability and reuse practices that let the intelligence operate reliably and at a scale. The third is like from forecasting to autonomous insights. So this chapter focuses more on like the shift from producing and just the producing the forecast to generating automated actionable insights, not just like and any anomaly detections that can trigger it's fully more of like how you can use your forecasting data to give you autonomous insights of your data. So uh, I would say the the key takeaway is like focus on the outcome driven systems, um, um, and um, and what the measurable business actions to deliver the value. The next chapter, I would say, is the agentic AI and the autonomous data orchestrations. So this chapter covers how agentic AI coordinates between the different data workflows, validations, the remediations, and cross systems. It also explains the human in loop pattern, the guardrails, the failure modes, and other orchestration requirements for safe autonomy. Um, uh, Next chapter is like building data products for an AI era. The product, um, so the data product mindset design features the ML data sets, the discoverability, the versioning, the consumer contracts. Everything is covered in this chapter. It also covers the product metrics and the operational ownership for the data products in this AI era. Uh, the intelligent data integration is another chapter where it talks about what the modern integration patterns are, what change a CDC can be captured, or a event-driven architecture. That a different architecture which I talk about in this chapter. Next is the approaches that can be taken to preserve the lineages and the semantics, which will enable the real-time flows. Um, so it's the integration must preserve meaning traceability. Moving data alone is not sufficient without semantic context and lineage. The next chapter is sustainable AI infrastructure. So now every like AI infrastructure is growing so rapidly, but how it can sustain is the common issue in the day-to-day use thing, right? So this chapter would cover more of like the financial cost and the environmental sustainability of the AI. So it talks about more of the model, the cost aware model, life cycle management, the right size compute, the caching, the reusing, and other governance practices that reduce the waste and the risk of the AI infrastructure. And last but not the least, I talk about the future of the intelligent data systems. This chapter covers about like the looking forward, what we can compose how we can compose the data platforms, how intelligent our data system can become, and how continuous the system can be autonomous. It can continuous learn and evolve. And then again, like we should also have a closer human and the AI collaboration. Uh, um, so human should always be in the loop of whenever we implement AI. We cannot just ignore the human involvement into that. So uh, so this is like the key takeaway again in this chapter is like the future will favor the adaptive, compose, and the governed systems. So it talks about the success requires architecture discipline plus the organizational learnings. Moving on to the last one, the key takeaway in this book is like the one message that I really want to share with the readers from this book is that AI success begins with strong data foundations. Intelligent platforms, real-time analytics, and agentic workflows only create lasting value when your architecture, your governance, and your executions are aligned. So the key takeaways are I would the first is like put the foundation first. The second would be like the real-time insight matters, and the third is the agentic AI has to be practical, responsible, and usable in a real enterprise environment. Thank you again for the opportunity to share my work. I'm really glad to be a part of this showcase and to connect with others who are interested in the future of the data and AI. Thank you again, everyone.
Thank you, Shitul. The future of data sounds